All right, test. Cool. Let's see. All right, so we have this render table function we wrote earlier today, and takes in two lists. So here's our header, and then we also have our programming languages that we're tabling. And so render table will take in a string list and a list of string list, which is our table rows. We'll then go ahead and calculate the max widths. So this function max widths will will provide it and pass on the header and rows functions. And then what it's going to do, it's going to map over where are we getting this out from? String list. Okay. So what we're doing is lengths L is a function that we're defining within max width. I don't know why that was confusing for me for a second. Anyways, so we basically construct this function lengths, which takes a string list, returns a int list, which is a list of the string lengths. So we're calling that a few times down here. And so we're going to fold our rows here. We're going to fold them together. So our initial accumulator value will be set to the lengths of the header. So the lengths of each string in the header. So this would be 8 and so on. Those links will be the initial links. And then we're providing fold with this function here, this anonymous function that takes in the accumulator, which is our init value at first. And it takes in one row at a time from rows. And so then for each row, we're going to call this map to exception. EXN is exception. So this map to throws a exception if the two lists that it's mapping over are of different lengths, which would be problematic when we're dealing with a table. We want to have all the rows to have the same number of columns. And so this map to EXN exception takes in a few arguments. So we take in the function int max, which will return the max between two integers, and then we take in our accumulator, which is again starts off as the lengths of the header strings. And then we also take in the lengths of the row that we're currently on. Because remember, we're folding each row, and then we're mapping over the individual strings in each row. And so what this map to is going to do then with this int max function is each string is going to compare. First, we're going to have, this is our accumulator, and this is the first row we're going to evaluate in rows. So we'll see that language and Lisp are of different length. So language is the longest, so because of int max, we're going to keep 8 as that first, that 0 index within our new list that we create from our map to exception function. And so we're going to continue on. Essentially, it's going to take the longest string of each column, and that will be the max width for each column. So then we'll have a single int list with the max widths of each column. And so that takes us back to here. So yep, we have our int list of max widths that we can use below. So here we're just going to concatenate this list here that we construct in place. And as we concatenate, we give the optional separator of a new line. That way we can have have the rows of the table on their own separate lines. And so this list that we're constructing here, we first construct the header row with this function render row. And render row takes a string list row, so we'll give it the header row, and then the widths. And what we're going to do here is get the padded strings of that row. So here again, we're using that map to exception function. And we're going to basically map through both of these lists together and apply this pad function. Now this pad function takes in a string, which is our whatever the string is of the row list, and then the length of that, which will be given with the widths, which have our max widths. So we then concatenate the string with a string we make in place here. Essentially, string make is going to make a string of some length of some character we give it. And the character we're giving it is empty space, because we want to space out our columns evenly. And so the length minus the length of the string, of course, so we can have, if you see here, these have different lengths within the same column. We want them to be, we want the borders of the columns to be lined up evenly. So we account for that here with the max width, which is our length for that column. And then we minus the string length from that. And that gets us the padded string version. And then finally we do another concatenation here to get the rest of our row characters. And that renders a row. So then we have our header row there. And then we're going to cons it onto this render separator. It just takes the widths and renders this separator, essentially doing the same thing as what was done with the render row, but just needing this int list. So we get the pieces by mapping over widths with this function, which is going to add dashes. And then we can concatenate all the pieces together. And then lastly, we have here, we map over each of the rows here to get the rendered version of each row. Similar to what we did here, but we're just mapping over this rows, which is a list of string list. So one thing I want to take a look at, just want to see how like something simple like int max is implemented under the hood. So we're using the base standard library instead of just the OCaml standard library, and here we have max and min. So max is going to take a two integers, and it's going to compare them. So if the first is greater than or equal to y, we're going to I'm not familiar with bool 0.select. But it takes in expression that evaluates to bool, and then our two ints. And it's going to return alpha. Wish we knew where this was defined. we'll see if we see this again sometime. But bool 0 dot select. Okay, so some other methods. Let's see strings out length. We never looked at that the other day. I wonder if it's just a wrapper over the I'm not familiar with external in the setting of OCaml. But my guess is it's importing it from string 0 defines string functions that are primitives or can simply can be simply defined in terms of standard lib.string. Okay. It's intended to completely express the part of the standard lib string that base uses. Let's do fold. So I'm guessing this is just a fold left. Where'd it go? Here we go. So it's recursive. Takes in alpha list. Has an optional, or not optional, a named parameter, or labeled parameter initializer or accumulator list. Takes in a function that has the type alpha, beta. I forgot what C stands for necessarily. I don't know. Then we do pattern matching. This empty list, we just return the accumulator. Alright, so we pattern match the list. And then we recurse the tail of the list. And then we modify our initializer with the function. We apply function f to to the initializer and head element. And when we pass on that function too. So then this would be tail recursive. Because this is all going to evaluate before we recurse into the fold. Do they have like a fold right? That's what I'm. wondering. Do have a fold right here. We have a fold to OK. Why is it don't save that. Our primitives. Yeah. Take a look at this standard library module again. Oh, is fold left. Here's the fold left. So yeah, it looks exactly the same. Just that we have F and our accumulator are labeled values within fold here. So, and that is our accumulator that's labeled, and then F is our F labeled parameter. So yeah, fold left is tail recursive. Fold right is not, because you have to recurse and then F is applied to both to the head and the value of this recursive call. And so the head, the first element in the list, is going to be the last to be applied onto, or you're not applying it onto it. The last F is going to be applied onto. So you're going from the rightmost element to the left, versus fold left, you're going from the zeroth element to the nth element. Okay, so that's fold. I think we took a look at list.map yesterday. Just take a peek at it again, might as well. And yeah, we're just doing the standard. Oh, this is this map here. So here we have our map function and our list we're mapping through, and count map. Takes everything plus, this is a accumulator. Just says int, let's see, counter. And this is count map is recursive, and woo, we are pattern matching up the wazoo. So if it's empty list, we would just return that empty list. If there is one element, then we apply that function to the one element in that list. And then return the evaluated product in the list. It's interesting. I'm gonna ask why it's structured this way up to 5. Why are we matching the first 5 and the first 4 there? 3, 2. See what this has to say. Has to do with optimization, of course. It's a trade-off between performance from inlining versus recursive calls. Non-tail recursive call. So if the count is over this max, then we are going to be doing tail recursion. Okay. Else we that, and that's the purpose of this counter. Okay. Where is this set somewhere? So max non-tail call depends on the backend type. If it's native or bytecode, it's 1,000. Or if it's other 50. If we don't know the size of the stack, better be safe and assume it's a number that was taken from OCaml standard library slash list.ml, which is also equal to the default limit of recursive call in the JS of OCaml compiler. So I'll see this being tail recursive. So this would reverse the representation with one heap allocated object per element, which is why it's more expensive and you don't want to necessarily do it. So you would prefer to do this regular count map, recurse back through it, if possible. All right, cool. What else do we got? We have this map to exception. I just want to see the exception portion of it. we have a check here, and then you do the map. Check length, two of list. Same length. Checks if two lists are the same length. Or two types are the same length. Equal lengths here, invalid argument F. Argument format. With mismatch in. This is the name that we pass in here. Somewhere here. And these two lists. Aside the lengths of them. D, yeah. This is unit, is it? Oh, evaluates unit. Yeah. So that's it. I just wanted to do a quick little review of what I wrote earlier, just to document it a little bit. Yeah, cool little project. Yeah, that's it. So I hope you guys have a good day. I'll see you next time.